Now identity 13 here is a plus b plus c whole square is equal to a square plus b square plus c square plus twice ab plus bc plus ca. Okay, this is what the application of this we are going to see. Application. Let us take this where I have to expand 2x minus 3y plus 4z whole square. Okay, now see here, this is of the form a plus b plus c, but except that I have a minus sign. So when I have a minus sign here, I will work with the minus sign. Okay, so what you do here is you compare this with a plus b plus c. What you see here is we can take a as 2x. You can take b as, because there is a minus sign here, you can work with the minus sign. That is, you can take b is equal to minus 3y. And you take c as 4z. Now we can expand. So therefore, 2x minus 3y plus 4z whole square is equal to a square. A is 2x plus b square. B is minus 3y plus c square 4z plus twice. Now you give a curly bracket. You have AB. So A is 2x. B is minus 3y. Then you have BC. So minus 3y into plus 4z. And finally, you have a CA. C is 4z and A is 2x. And you close the curly bracket. And now you just simplify this to get your answer. 2x whole square is 4x square. Minus 3y whole square is 9y square. 4z whole square is 16z square. Plus twice. Now if you multiply these two, how much are you going to get? You're going to get minus 6xy. You multiply these two, you're going to get minus 12yz. And you multiply these two, you're going to get plus 8zx. And that is your answer. If you want, you can multiply all this also. 4x square plus 9y square plus 16z square. You can multiply all this with 2. So you get minus 12xy minus 24yz plus 16zx. Okay, this. So even if you keep your answer here, it's no problem. Okay. So this was one application of a plus b plus c whole square. And finally, you have the last identity, 14. Identity number 14. 15 I'm not going to show you because 15, as I said, is not a very important identity. If you remember, it will be for your own good. Identity 14 was if a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc. Okay, this was our identity, and we'll see one application of this identity here. Let's take this very simple sum. Sum is if a plus b plus c is equal to 0, then find the value of a square by bc. This is an important sum, okay? Remember, this is not as simple as the earlier applications. C square by AB. You need, if it is given to you that if a plus b plus c is equal to 0, then you need to find the value of this. Okay. So we start, since we have to find out the value of this expression here, let us start with this expression. So we have a square. Before starting, let me just write this. Now remember, we will be using this identity. It is given to you that a plus b plus c is equal to 0. And we know that if a plus b plus c is equal to 0, then we have a cube plus b cube plus c cube is equal to 3abc, right? We know this. We shall be using this. So we start from now this. So we have a square by bc plus b square by ca plus c square by ab. Okay, now you see here uh, that in all of these, or what you can do is you can take the LCM simply. The LCM should be ABC, and see here ABC when divided by BC will give you an A, and A into A square will give you A cube. Plus, now you have a CA. ABC when divided by CA will give you a B. You have B square into B, which will give you a B cube. Similarly, here you have C cube. Okay, so once you take the LCM, now you know that if A plus B plus C is equal to 0, then this must hold, right? Because A plus B plus C is equal to 0, then A cube must be plus B cube plus C cube must be equal to 3ABC. So here in the numerator, you see A cube plus B cube plus C cube is equal to 3 is there. You put it equal to 3ABC. And the denominator, ABC is there. What will happen? ABC will cancel. You simply get 3. Is that absolutely clear, this problem? Or anything that needs to be explained?
So it's clear.
We'll move to the, now once we have shown the application of each of the identities, now we shall,
Excuse me, sir.
tell me.
Sir, can you please?
I'll give you certain sums from the textbook itself. Okay, let's just write the sums first. The question problem here is simplify. You can check the numbers in your textbook. Okay, simplify. First question here is 3x minus 1 whole square minus 3x minus 2 into 3x plus 1. Okay, next sum here is x plus 2 by x minus 3. Now please have your identities ready in front of you. If you don't remember your identities, please have it ready in front of you, because each time I'm not going to write the identity if you haven't learned up, and later on don't say that you haven't understood, because you cannot learn up the identities. That is why you're not understanding. Even if you have not learned it up till now, just keep your where you have copied your identities or your textbook, just keep your identities ready, so that when I'm working out the sums, you can compare. Who is Saurav in your class? Who's Saurav in your class? Anyone?
Yes, sir.
Okay, this is it. Let us finish these 6 sums very quickly. Very, very easy sums. So, first one, you need to simplify 3x minus 1 whole square minus 3x minus 2 into 3x plus 1. Okay. Now we are going to use a minus b whole square to simplify the first one. So the first one here is a square minus twice a b plus b square minus. Now if you see the second part here, it consists of a product of these two, right? If you compare this with x plus a into x plus b, so you get a as your 3x and b as the x as your 3x, and you have a as your minus 2 and b as your plus 1, isn't it? So we'll put it under curly brackets. What was x plus a into x plus b? It is x square, but a here is 3x. So you'll have 3x whole square. X square plus a plus b. What is a here? A here is minus 2. B here is 1. So x square plus a plus b into x. X here is 3x, right? Plus ab minus 2 into 1. Is that clear to all?
Yes, sir.
Now you have 9x minus 9x square, and this is your minus 3x, and this is your minus 2. Now you open the brackets. All the signs will change. So plus 9x square minus 9x square is going to cancel. And you have minus 6 plus 3, you have minus 3x. Plus 1 plus 2 will give you a 3. So you can write this as 3 times 1 minus x. And that is your answer. Okay, let us see the second one. What we have for the second one? Second one is x plus 2x minus 3. X plus 2 by x minus 3 into x minus 2 by x minus 3. See, notice something very interesting here, that x and minus 3. You have plus x and minus 3. Here also you have plus x and minus 3. But here you have a plus 2 by x, and here you have a minus 2 by x, right? So what you do is you take x minus 3 together for the first one and write 2 plus 2 by x separate. For the second one, again you take x minus 3 together and you write minus 2 by x separate. So now what do you see? Something very interesting that you see here. Can anyone observe and tell me what interesting thing that you see here? This is a
So,
plus, yes, tell me.
so it's plus 2x, 2 by x, and it's minus 2 by x,
Yes.
which can be cancelled.
No, it cannot be cancelled. What you see here
Sir,
is that this is
Sir, a plus b, a minus b.
exactly a
Yes.
plus b and a minus b, which you know is equal to a square minus b square. So if you consider this entire x minus 3 as your a, you're going to get a square minus, and b as your 2 by x, if you consider, you're going to get b square. Okay, no problem here. We'll continue with the next step then. Now what you do is you expand everything. So you have x square minus, this is a minus b whole square expansion, plus 3 square minus 2 square by x square, and finally you get your answer, x square minus 6x plus 9 minus 4 by x square. and that is your answer. Okay, move on to the next one. Identities are very, very important. 5 minus 2x, 5 plus 2x. Into 25 plus x squared. 25 plus 4x squared. Let us see. Now, if you consider the first two, you see that this is a minus b and this is a plus b, the first two products. So if you multiply these two, you're going to get a square minus b square, right? So if you multiply these two, you're going to get a square, which is 5, minus b square, which is 2x, right? You're getting a square minus b square. And the third factor, you write as it is, 25 plus 4x square. Next one, you have simplify this, 25 minus 4x square. And here you have 25 plus 4x square. Now what do you see? You again see a plus b, a minus b form. This is your a plus b and this is your a minus b form, right? Where a is 25, b is 4x square, which must be equal to a square minus b square. A square here is 25. This is 25 square and b square here is 4x square. So that is you get here 625 minus 4 square x square square. So you get 625 minus 16x to the power of 4. Okay, and that is your answer. And see the next one, number 4. Number 4 here is 3x minus 4y minus 2, 3x minus 4y minus 6. 3x minus 4y minus 2, 3x minus 4y minus 6. Okay. Now what you see here is that for the first one, this is the same, right? 3x minus 4y is here, 3x minus 4y is here. So you can consider this as your x. And here you have a minus 2, so x plus a. And this is again, if you consider this entire part as your x, this is your plus b. So what do you see? X is 3x minus 4y, a here is minus 2, b here is minus 6. So what is the formula for x plus a into x plus b? It is x square. Here x is what? 3x minus 4y whole square. Next you have plus a plus b into x. So a, put it in curly brackets, plus a plus b into x. X here is 3x minus 4y, right? And you have a plus a minus 2 into minus 6. And therefore you get 3x minus, let us expand this, 3x minus 4y whole square by a minus b whole square formula. So a square minus twice a b plus b square. And here you have minus 2 minus 6 will give you a minus 8 times 3x minus 4y, right? And here you have plus minus 2 into minus 6 is plus 12. So what you get here is 9x square minus, you have, if you multiply all this, you get 24 xy plus this is 16y square, right? That's 16y square, and this is minus Now if you multiply this, 8 into 3 is 24x. This minus sign will combine to give you a plus sign, or if you're yes, it will give you a plus sign, and 4 into 8 is 32, y plus 12. And I think that is simplified. Yes, no like terms here, so that's your answer. Any questions here? Move on to the next one then.
Excuse
Number
me,
5.
sir.
Yes, tell me.
Sir, there are two Sampurnas in the group.
Okay, one has left already. Number 5. Question is x minus 3x and you have x square plus 3 plus 9 by x square. Okay, so in order to simplify this, what you see here is that this is of the form a. If you take x as your a and this as your b, very interestingly you see that this is a square here, you have a b square here, right? So this should be of the form ab, then only you can get a cube minus b cube, isn't it? This should be of the form plus ab, right? So let's see whether this is plus ab. We just need to check this term whether this is plus ab. Okay, it should come, so we'll see. So this is x minus 3 by x into a square, and you write a b square plus ab is a into b. Okay, so what are you getting here? This is now, this is what form? A cube minus b cube form. So this is a cube minus b is 3 by x cube. So you get a cube minus b cube, and that is your answer. Okay, let us see the last one here. Last one here is this 2x plus 3y plus 4z into all this. Let's write this. 2x plus 3y plus 4z into 4x square plus 9y square plus 16z square minus 6xy minus 12yz minus 8zx. Okay, now if you see, this looks like your a plus b plus c. This one, if you take a as 2x, b as 3y, and c as 4z, then this is your a square, this is your b square, and this is your c square. So what does it look like? It looks like a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, isn't it? Minus twice ab minus twice bc minus twice ca. It looks like that. So we'll try to see what form this is, which is equal to what? A plus b plus c whole square. So we'll try to bring it to that form. Okay, so what you do here is to write this as 2x plus 3y plus 4z, and 4x square you write as 2x whole square. This is your a square plus b square plus c square, right? And what was the form? Twice ab plus bc plus ca. Now see here, I have minus signs. So how can I get minus signs here when all are positive, right? Now you need to be very careful with these combinations. Okay. 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 So this is not a plus b plus c whole square form. This looks like identity 15. Yes. You've got an application of identity 15. Someone was asking identity 15. You've got an application here. So this is minus 2x into 3y. So you've got a square plus b square plus c square minus ab you have got, right? Minus ab you have got. And you have got, now you see that minus, you have 3y into 4z will give you a 12z. So this is also, bc is also here. Okay. And similarly you have zx 4z into 2x will give you 8zx, right? So what is this form now? This becomes your identity 15. A plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, which must be equal to what? A cube plus b cube plus c cube minus thrice abc. You have a cube plus b cube plus c cube minus thrice a b c. So you have here 8x cube plus 27y cube plus 64z cube, and if you multiply all this, will give you a 96 xyz. 92, I think. Yes, 92. Okay, 92 xyz. That's it. Okay. Any questions here?
No, sir.
We'll do just one more problem and we'll finish this. Okay. Question here is, if a square plus 4a plus x is equal to a plus 2 whole square, find the value of x. Okay.
Excuse me, sir.
Yes, tell me.
Sir, it will be 72 XYZ.
72. Okay. Previous one. So this will be 72. Okay. Coming back to this. This is your question. If a square plus 4a plus x is equal to a plus 2 whole square, find the value of x. We start from here. We have a square plus 4a plus x is equal to a plus 2 whole square. This is given to you. Now see, you have on the right hand side here, this is your perfect square, right? But here this is not your perfect square, right? So we try to make this part, that is your left hand side, as your perfect square. Okay, so how do we do it? This is your a square term, right? And Okay, this is your perfect square. So what you do here is you expand the right hand side. Instead of expressing this as your, since you need to find the value of x, you expand this side by a plus b whole square formula. Okay. So you have a square plus twice a b plus b square. We have a square plus 4a plus x is equal to a square plus 4a plus 4, right? Now what you do is, you see on both sides you have a square plus 4a. You take the a square plus 4a's together. Plus x equal to a square plus 4a plus 4. Now what you can do, this a square plus 4a is the same. That means x must be equal to 4. So equating like terms on both sides. We get x is equal to 4. And that is the value that was required.
So can you explain also?
Which part? Tell me which part from the beginning.
The last part.
Yes,
The last part.
last part. See, this is a square plus 4a is here also, a square plus 4a is here also, right? Isn't it? So what I have done is I have taken these two within brackets, right? Because a square plus 4a is on both sides. And x I have taken separately. On this side I have taken 4 separately. So a square plus 4a has like terms, right? But x is only the unlike term on the left hand side and 4 is the unlike term on the right hand side. So what I have done is, if these two are equal, then these two must also be equal, because you have an equality sign in between. Two algebraic expressions are equal. So that is why equating like terms on both sides, we get x is equal to 4. Any question or any other doubt? I'll stop here then.